everyone. Thank you so much for being here. Today I will be presenting a paper by Triandopoulos from 2018 called Computerized Decision Support in Physical Activity Interventions, a Systematic Literature Review. So this paper looks at how digital decision support tools are being used to help people become more physically active and whether these tools actually seem to work or not. So moving on to the introduction slide here, the paper starts from a pretty straightforward point. We already know regular physical activity is good for health and quality of life. The challenge is that many people still struggle to stay active over time. Traditional interventions can help, but they are often hard to personalize, hard to scale, and hard to maintain in everyday life. So the author are seeking whether computerized decision support, things like digital coaching, personalized prompt, and monitoring systems might help make physical activity interventions more effective. Moving on to the next slide, why this matter. This matters because physical inactivity is still a major health issue. A lot of interventions are designed to encourage behavior change, but not all of them provide the kind of ongoing tailored support that people need. New technologies, especially mobile and sensing technologies, they make it possible to offer more personalized feedback and closer monitoring. So, this review is really about whether that potential is being used well or not. So, moving on to our research objective. The main objective of this paper is to review recent research on physical activity interventions that use computerized decision support. The authors want to know how these systems have been designed, whether they are feasible, whether they are effective, and what challenges still remain for future research. Moving on to the research question here, the paper does not formally test hypothesis since it is systematic literature review, but it clearly revolves around several key questions. For example, what kind of physical activity interventions are using computerized decision support in real life settings? How can these interventions be grounded by user type, technology, and decision support features? What evidence is there that they are feasible or effective? And finally, what gaps or future needs does literature reveal? The next slide here is the type of study. This is a systematic literature review. As I said, that means the authors are not collecting original participant data themselves. Instead, they review and compare previously published studies in a structured and organized way. Moving on to the methodology here. To carry out the review, the authors searched two databases, PubMed and Scopus. They are specifically looking for physical activity interventions that use computerized decision support in real life context. In the end, they include 24 studies in this review. So the methodology is systematic in terms of search and selection, and then descriptive in the way descriptive in the way that it includes studies that are analyzed. Moving on to the next slide, data. The data in this paper are the 24 published studies included in the review. These studies covered both healthy individuals and people with health conditions. The author looked at things like participants' numbers, how engaged people were with these interventions, what outcomes were measured, and how long follow-up lasted. Moving on to the next slide here, which is the empirical model or analytical framework. This paper does not use an econometric model or meta-analysis. Instead, the author used a structured synthesis framework. They grouped the studies according to target user group, type of technology, decision support features, theoretical model, study design, primary outcomes, engagement, and follow-up durations. So the analytical approach is really about organizing and comparing the evidence in a systematic way. Moving on to the next slide, what is our target population? One of the first finding is about who these interventions were targeting. The largest group was sedentary but otherwise healthy individuals, which accounted for 7 studies, which was roughly around 29%. After that came people with pre-diabetes or diabetes with 4 studies, so I would say roughly around 17%. Then overweight individuals, again, they were there for 4 studies, which was again roughly around 17%. So the field is not limited to patient with diseases, it also included prevention oriented interventions for healthy but inactive people. Moving on to the next slide here, which is the intervention features. The review also looked at what kind of decision support features these systems were using. The most common features were personalized goal setting, which appeared in 16 studies, so roughly around 67%. Close behind that was motivational feedback, which was used in around 15 studies, so again around 63%. Then there were some other features like alerts to caregivers were much less common. They appeared in around 4 studies, so around 17%. And integration with electronic health records, also known as NAS EHRs, was even less common, which was around 13%. That tells us the most system focused more on user level coaching than on clinical integrations. Moving on to the next slide, technology and measurement. Another important point is how physical activity was measured. The review found that accelerometers or pedometers were used in 11 studies, which was around 46%. That means objective sensing was used in almost half of the interventions, which is encouraged, but also means that there are still a lot of room for improvement. The author suggests that future work would make more use of objective activity measurements. Next one is the key results. In terms of results, the findings were generally promising. Most randomized controlled trials reported significantly positive effects. For studies that measured physical activity directly, there were 7 out of 7 reports increased physical activity. Among studies looking at diet-related outcomes, there were 3 out of 4 reported positive effects, such as weight loss. And among studies assessing the hemoglobin, there were 2 out of 3 report reductions. So overall, the evidence points in a positive direction, even though the field is developing. Moving on to the theoretical model and limitations. One of the biggest weaknesses the review points out is the limited use of theory. In fact, 14 studies, which was roughly around 58%, did not report a theoretical model for behavior change at all. That is a very big issue, because if these systems are supposed to support behavior change, they should really be grounded in a clear behavior framework. So while the interventions are promising, many of them are still missing stronger theoretical foundation. Moving on to the next slide here, which is the implications and future direction. The authors conclude that computerized decision support has real potential to improve physical activity and health outcomes, but they also make it very clear that future studies need to be more specifically in 3 areas: using object sensing devices, connecting better with clinical systems, and building interventions around behavior change theory. Those steps would help move the field from promising digital tools to more evidence based and scalable intervention system. Moving on to our final slide here, which is the conclusion. So to wrap up this paper, it gives us a useful overview of how computerized decision support is being used in physical activity interventions. The findings are encouraging, especially around physical activity, but the paper also review a clear gap in theory, clinical integration, and objective measurements. Overall, the paper supports continued development of these tools, but with stronger design and evidence behind them. So I will take any questions that you guys have in the comments below. Thank you. Bye bye.